Hi guys, okay, this is the June 2018 paper 2H, which is the regional one, so just don't get confused with the other paper. Anyway, you'll see straight away if it's the correct paper that you're doing. Question 1. Again guys, there's 24 questions. Write your answers in the spaces provided. You must show your working. So, question 1, I think this is actually a kind of tricky question to start with, but x, 10, and y are three integers written in order of size, starting with the smallest integer. So x is the smallest, y is the biggest. The mean of x, 10, and y is 11. The range of x, 10, and y is 7. So guys, you could almost try and kind of guess or figure out what these questions are. I'll show you the more technical way of doing it though. If the mean is 11, that means x plus 10 plus y, the three numbers added together, divided by 3, has to equal the mean, which is 11. Then, if I just solve this, I can say, well, not solve it, but multiply across by 3. X plus 10 plus y equals 33. And x plus y equals 23 because I subtract the 10. So now I have an equation, x plus y equals 23. It says the range of x, 10, and y is 7. Now the biggest number is y, because it says it's in order of size, and the smallest number is x. So y minus x is equal to 7. That's the range. Biggest minus smallest is equal to 7. And now you can, well, you have two equations. You can solve them simultaneously however you like. So look, x plus y equals 23. I can put y minus x, or okay, minus x plus y equals 7. That's just the same as y minus x plus y. And then I can add them together to eliminate the x, and I get 2y equals 30. 23 plus 7 is 30, and y is equal to 30 divided by 2, which is 15. And once I have y, it's easy to get x, because 15 minus something is equal to 7. Well, x has to equal 8, because 15 minus 8 equals 7. So now I have x equals 8, y equals 15. If that seems like too much for you guys, you can always almost guess what the numbers are. Well, it's nice to get to this stage first, at least. You know that the three numbers added together have to equal 33, and then just find out what these two numbers are. But obviously the way I did it is probably the best way to do it. Okay, question 2. It tells us pressure is equal to force over area, although you should know that. A box is put on a table. The face of the box in contact with the table is in the shape of a rectangle, 2 meters by 1.25 meters, right? So that's the first bit of information. It says the pressure on the table due to the box is 42 newtons per meter squared. So that is the pressure. Work out the force. So basically, we have the pressure. We're going to have the area using this, and we'll just find the force. So the pressure is 42. Well, actually, first, guys, let's find the area. The area is equal to 2 times 1.25. Base times height, or base times width, or width times length, however you want to say it. 2 times 1.25 is 2.5. So the area is 2.5. Now I have the area and I have the pressure. So I'm going to say 42 is equal to force, which is the thing I don't know. Let's just call it F. Force over area, which is 2.5. How do I get F on its own? Well, I have 2.5 in the denominator. If I multiply this 42 by 2.5, let's do that over here. 42 times 2.5, I get 105. So F is equal to 105, and it's in newtons, which is given here. So it's 105 newtons. Okay, not too bad a question. Question 3. Benaz makes candles. She has 63 kilograms of wax and uses it all to make candles. Each candle she makes uses 210 grams of wax. Okay, so the first thing I'm going to do, guys, before I even read the question, is find out how many, although I have read the question to be fair, how many candles is she going to be able to make with the 6.3 kilograms. So I'm going to change that to grams because it's 6,300 grams, 6.3 kilograms, and I'm going to divide by 210. This will tell me how many candles she can make. 6,300 divided by 210 is 30, right? So she can make 30 candles. She sells 2/5 of the candles for $13 each, right? So I'm going to get 2/5 of 30. 2/5 of 30, which is like 2/5 times 30, or divide by 5 is 6, multiplied by 2 is 12, right? Either way, guys, you should be able to get 2/5 of 30. So she's going to sell 12 candles at $13 each. So I'm going to do 12 times 13, and 12 times 13 is 156. Okay, so she has made so far $156. She then reduces this price by 20% and sells the rest of the candles. Okay, so she has sold 12. I'm just going to write here, she has 18 left. So she's 18 candles left because she sold the 12. Okay, what's she going to sell them at? What price? Well, I have to get 20% less, or reduce $13 by 20%. The way I like to do that is multiply by 0.8, because 20% less is 80%. So I'm going to get 80% of 13. What is 80% of 13? Well, it's 13 times 0.8, and S to D, start to decimal, 10.4. It is 10.4. So she's now going to sell these 18 at 10.4, 1040. So I'm going to do 18 times 10.4. 10.4 times 18 gives me 187.20. 187.20, and that is also dollars. The question says work out the total amount that she's made. So I'm just going to do 156 plus 187.20, 343.2, 343.20, because it's dollars, and down here I'll write 343.20. So that's how much, that's the total amount of money that she gets by selling all the candles. Okay, done. Question 4. So expand and simplify this, guys. Hopefully is straightforward. So 3 times c is 3c. I'll put equals here. 3c, 3 times 7 and minus 7 is minus 21. Plus 2 times 3 is 6c. Plus 2 times 4 is 8. Simplify it, collect like terms. 3c plus 6c is 9c. Minus 21 plus 8. Use your calculator, guys, if you have to. It is minus 13. So it's 9c minus 13. Next one, I'm going to do this times this, this times this, this times this, this times this. X times x is x squared. X times negative 2 is minus 2x. 7 times x is plus 7x. And 7 times negative 2 is minus 14. Again, guys, collect the like terms. X squared minus 2x plus 7x is plus 5x minus 14. X squared plus 5x minus 14. Question C. Factorize fully this. So we need to take out the highest common factor of 28 and 21, which is 7. I then need to take out a y from each because there's a y in each term. And then I need to say, what do I multiply to give me this? Well, it's 4 to give me the 28. 4 times 7 is 28. And another y to give me the y times y equals y squared. And then this guy, I need a minus. I need a 3 to give me the 21. And that's it because I have the y. So that's all I need to write. It's 7y into 4y minus 3. Part D. Solve this, show clear algebraic working. So I'm going to say 7x minus 2, because guys, there are calculators that can just, including mine, they can just solve this straight away, but when they say show clear algebraic working, they want you to work it out properly. So I'm going to multiply across by 4. So I'm multiplying this side by 4 like that. Then I'm going to multiply out, so equals, multiply out the bracket, minus 2. Or sorry guys, I don't need these two equals because I have an equals. So 4 times 3x is 12x, and 4 times 1 is 4. Then I can get, guys, if I want, let's leave the x's on the right, and I'll put the numbers on the left. So I'll do minus 2 minus 4, subtract this 4, equals 12x minus 7x, subtract this 7x. I get negative 6, 12 minus 7 is 5x, and then finally x equals negative 6 over 5. Negative 6 over 5. Okay. Question 5. Abeli flew by plane from Dubai to Rome. The flight time was 6 hours and 42 minutes. The average speed of the plane was 650 kilometers per hour. Work out the distance flown by the plane. Right? Distance, guys, is equal to speed times time. You need to know that. It's the speed, however long. If you're going 50 kilometers per hour for 2 hours, you'll go 100 kilometers. So distance is speed times time. The speed is easy. It's 650. But the time, and this is, guys, the tricky bit of this question, lots of people no doubt will do 6.42, but that's obviously a problem because it's 42 minutes, not 6.42. So I need to say, what is 42 as a decimal out of 60? So 42 out of 60 as a decimal, because there's 60 minutes in an hour. So think about it. When you see 42 and I write 6.42, this should be more than 6.5 because it's more than 6.5 hours. So just keep that in mind when I get my answer. So it should definitely be more than 0.5. Press equals, and it's 0.7. So this is equal to 0.7. So it's 650 times 6.7 because it's 6 hours and 42 minutes. 6 hours and this. And that's it. That's the hard bit done. All I need to do now is do 650 times 6.7. And I get 4355. 4355. 4355 kilometers. Question 6. Hiran invests 20,000 rupees in an account for 3 years at 1.5% compound interest. 3 years, 1.5%. Work out the total amount of money in the account at the end of 3 years. Give your answer to the nearest rupee, right? That's a nice question, guys, because I know the formula. It's just 20,000. There's nothing tricky here. Times 1 point, maybe the only tricky thing is it's 1.015. The percentage, you got to do 1 plus the percentage. And 1.5% as a decimal is 0.15. So I have to do, oh sorry, 0.015. So it's this, and I have to do to the power of 3 because it's 3 years. My calculator can do the hard work. 20,000 times 1.015 to the power of 3, 20913.56. 20913.56 or 0.57, but it actually says to the nearest rupee. So this is, I'll just put it down here, 20914, because I'm going to have to round that up because of this 0.57. Okay. Question 7. Simplify fully. Okay, this, guys, is equal to 20 divided by 4 is 5. X squared divided by x squared, well, they actually cancel because they're the same thing. Anything divided by itself is 1, so they're gone. And then y to the 6 over y squared, that is my second rule of indices. I just subtract the powers. So 6 minus 2 is 4. So it's just 5y to the power of 4. Make E the subject of the formula. Okay, first thing, let's just change it around. So instead of saying h equals 3e plus f, I'll do 3e plus f equals h. Then subtract f, so it's h minus f. And finally, divide by 3. So it's h minus f divided by 3. H minus f over 3. Not the worst changing the subject question. Question 8. From point A, Stanley walks 200 meters east, and then he walks 160 meters south. Right, definitely, guys. First thing to do, put in point A. Then he walks 200 meters east to point B. So this is point B, and this is 200 meters. From point B, he then walks 160 meters. It doesn't have to be perfectly accurate, guys, but this will be less than this. So it's 160 meters down here to point C. Work out the length of AC. So, guys, this is just kind of disguised a Pythagoras' theorem question, because if this is east and this is south, then this is a right angle, which means we can use Pythagoras' theorem. Let's call it x. I'll say x squared equals 200 squared plus 160 squared. X squared equals, let's do that. You can do this in one step if you want, guys, but I'll just do 2 steps. 200 squared plus 160 squared is 65600. 65600, and then you have to, and do not forget, to square root 65600. If this is 200 and this is 160, obviously, guys, this is not 65,000. So we need to get the square root. I'll do square root of the answer is this, and I will turn it into this. It's 256.124. 256.124 or 125, I think it was, but he wants it to 3 significant figures. 1, 2, 3. This is my third significant figure. I look to the right, it's a 1, so I'll just keep it at 256 meters. Okay, question 9. A diagram shows a regular pentagon. This is a pentagon. A regular octagon, this, and an isosceles triangle BCF. Work out the size of angle X. Okay, so that's X. This, I guess, guys, is also X because it's an isosceles triangle. I'll just put that in to begin with. Okay, in a pentagon, the interior angles, guys, add up to what? Well, if you remember, the formula is n minus 2 times 180, where n is the number of sides in a polygon. So in a pentagon, it's 5 minus 2 is 3, so it's 3 times 180. 3 times 180, that's 280. 3 times 180, I should know that, it's 540. So the interior angles in a pentagon is 540, and then in an octagon it'll be 6 times 180. So maybe, guys, I should have just written here what I'm doing. So it's 3 times 180, and this guy is 6 times 180. 6 times 180, 1080. Okay, now because these are regular, polygons, I can just divide this by 5 and divide this by 8. So I'll just do that over here. 540 divided by 5 is equal to 540 divided by 5, 108, and 1080 divided by 8 is 1080 divided by 8, 135. That means this angle here is 108, because, let's use a different color, guys. This is 108 because they're all 108. This is 108. This is 108, etc. But well, I'll put them all in. This is 108 and this is 108. But I only care about this one, and I'll show you why in a second. Similarly here, guys, these ones are all 135. So this angle here is 135. That angle there. So where am I going with this? Well, look, if I can find B, this is obviously a tricky angles question, guys. If I can find, CBF, so angle CBF plus 108 plus 135, that's these three angles around this point have to equal 360 because they're angles around a point, or it's just a full circle. Therefore, angle CBF equals 360 minus 135 minus 108, which is 117. So this is 117. So this angle here is 117. Now, I'm not done. I have to find angle X, but I know that X plus 117, let's write that down, X plus 117 has to equal 180, because these are the angles in a triangle. Angles in a triangle add up to 180. And I know these are both X because it's an isosceles triangle, because it says it here. Isosceles triangle means these two lengths are the same and these two angles are the same. Okay, so let's just solve this. X plus X is 2X. 180 minus 117. 180 minus 117 is 63, so 2x is 63. X is 63 divided by 2. I can do that in my head, guys. Is 31.5, and it's degrees. So this is 31.5 degrees. Okay, question 10. It says here ABCD is a trapezium. Trapezium, guys, means that their two sides are parallel. So this side and this side is parallel. Work out the sides of angle X. Give your answer correct to one decimal place. Right, that, guys, is a little bit tricky. The only way to do this is to draw a line. I can't think of another way. I have to draw this line down there. Once I have this line, I know that this is a right angle. So now all I need to do is find this angle, this green angle. How can I find that green angle? Let's call it Y, by the way. Let's call that angle Y. I know this length is 12.5 because it's the exact same as this length. And this length here, let's draw a purple line here. This length has to be 24.3 minus 16, because it's the whole thing minus this amount. And 24.3 minus 16 is 8.3. Now I have, and this, by the way, guys, is a right angle, but now I have a right angle triangle. I know two sides. It is SOHCAHTOA. SOHCAHTOA. I have the opposite and the adjacent. Opposite, adjacent, opposite, adjacent. Which one has the two ticks? It's TOA, so I have to use tan. So I'm going to say tan of y, because it's this angle, tan of y is equal to opposite, 8.3, over adjacent, 12.5. And then I can go straight to y. It's the inverse tan of 8.3 over 12.5, which is equal to inverse tan 8.3 over 12.5, and it's 33.58. 33.58. Now I'm not going to round yet, guys. It does say 1 decimal place, because I'm not done. That's angle y. X is this full angle, so angle x is equal to 33.58 plus 90. I have to add on that 90, which is 123.58, and then to 1 decimal place, it's 123.6 degrees. Okay, question 11. Okay, so this is a frequency table, and it shows information about the amount of money spent on holidays by each of 120 families. Okay, so 10 families spent between 0 and 100 pounds, 36 families spent between 120 and 200 pounds, etc. Write down the modal class, right, guys? This question often throws people because they don't know what modal class means, but modal it's the mode. What is the mode? And the class, these are the classes. So the mode is this one, because 36 families, the most amount of families spent between 100 and 200 pounds. So the modal class is 100, between 100 and 200. Part B, complete the cumulative frequency table for the information in the table, right? So cumulative frequency, guys, means basically just add up the numbers as you go along. The reason being because it now, instead of going from, well, it goes from 0 to 100, which is 10, but now it goes from 0 to 200. So that's both of these, because it's the 0 to 100 and the 100 to 200. So that's 46, 36 plus 10. And then 0 to 300 is all of these three, because these are less than 300, these are less than 300, and these are less than 300. So I add 34, which is 80, add 20 is 100, add 15, 115, and add 5 is 120. Okay, now on the grid, draw a cumulative frequency graph for your table. Right, I'll just go up to the table, guys. The points I'm going to draw are the end points of the classes. So this 110, 246, 380, 400, 100, 500, 115, and 600, 120. Those are the points. So my first point is 110. 110, like that. So 110 is there. Next one is 246. So these are going up in 2, so that's 46 there. And then I have 380. So 380. Then I have 400, 100, 500, 115. So that's 110. 115 would be here, right in between these two. And then 600, 120, that's at the end there. Okay, now I have to start at 0, guys, because the table starts at 0. Here, 0 to 100. It doesn't always start at 0, but in this case it does. So I'm going to start at 0 there. Now, guys, I always give a little disclaimer here that my drawing of graphs with this pen, this electronic pen I have, is not great. So you need to do, straight away, you need to do better than me. Make sure you go through all the points, and it should look like a nice curve. It shouldn't be just straight lines. Okay, that's not too bad, but it's not perfect. Anyway, let's see what the results come out like. It then says, use your graph to find an estimate for the interquartile range. Okay, so guys, there's 120 people. I need to divide by 4 to find Q1. Divide by 4 is 30. Q1 I will find from going to 30 and then going down here. This is 150, 160, so this would be 160. Q3 I then find by getting 3/4 of 120, so let's do 30 times 3, which is 90. So the 90th person or family will be my Q3. So I need to go over to here and then down like this. This is 310, 320, 330, 340. Obviously use a ruler, guys. There we go. So the interquartile range, the IQR, is the upper quartile, 340, minus the lower quartile, 160, which gives me 180. Now the mark scheme says accept anything between 175 and 180, so luckily it does accept it. I guess if you drew a perfect graph, you'd have somewhere in between them, which would be 190, so my graph is not perfect. Anyway, it says, for part E, use your graph to find an estimate for the number of families that spent more than £450, right? So I need to go to £450, which is here. I go up and across there. Now these are 2, so 102, 4, 6, 8. This is 108. But the question says how many families, estimate how many families spent more than £450. 108 spent less than £450. So what's left between there and there? Well, 12. 180 minus 180. So there's 12 families there that spent these kind of big bucks on holidays. So I'm going to do 120 minus 108. 120 minus 108 equals 12. Mark scheme says except 12 or 13, so obviously that's fine. Okay, question 12. Circle theorems. A, C, D are points on a circle center O. A, B, and C, D are tangents to the circle. Angle ABC is 74 degrees. So basically what you see, guys, here, work out the size of angle ADC. So this is the angle we are trying to find. Okay. First key bit of information it gives us, guys, is tangents to the circle. If they're tangent, that means the tangent and the radius, which is this line, and same over here, the tangent to the tangent and the radius meet at right angles. So that's a right angle and that's a right angle. Now, interestingly enough, let's call this angle X. This angle plus this angle plus this angle plus this angle have to equal 360, because this is a quadrilateral. Look, 1, 2, 3, 4. Let's draw that again. 1, 2, 3, 4. This is a quadrilateral. It looks a bit like a kite. I think it actually is a kite. So those 4, my X plus 90 plus 90 plus 74 has to equal 360. Hence, x is equal to 360 minus all of these. 360 minus 90 minus 90 minus 74 equals 106. So that x is equal to 106. Now, why does that help us? Well, look, these guys, this is the angle at the center of a circle, and this is the angle, let me just pick a color here. This is the angle at the circumference. And one of the rules of, one of our circle theorems is that this angle here, let's call it y, is a half of this. This angle is double this angle here. So I can actually say I need 2 y's just to equal 106. Or this is half of this, whatever way you want to write it. Y is then equal to 53 because it's the angle at the circumference is half the angle at the diameter. Now it doesn't say, guys, give a reason for each step, but it does say show you're working clearly, so you have to show something. Certainly what I've done is enough. And guys, they award marks for what they see in the circle. So I always draw all over the circle, write all over the circle in the lines, and show write in any angles that you know. Okay, I should write it down there too, guys. That is 53. Okay, question 13. So line 1 has equation 6 minus 2x. I'm just going to draw it, guys. Why not? 6 minus 2x, it's going down that way. It doesn't have to look perfectly, but this is y equals 6 minus 2x. The straight line L2, this is L1. The straight line L2 is perpendicular to L1 and passes through the point 4, 7. So let's draw another line. Perpendicular and passes through a point 4, 7. Let's just say 4, 7 is here for the fun of it. Well, actually, well, whatever. It's for here, 4, 7. Find the coordinates of the point where the line L2 crosses the x-axis. Okay, fine. This actually, guys, is a tricky question. But what it is the equation of a line for a perpendicular line. So what do we do? And this, by the way, is L2. The gradient for L1, I want to find the equation of L2. To find the equation of L2, okay, let's write this down. Find equation of L2. We need the gradient and a point. The point is 4, 7. We have that point. Don't know why I'm writing in pink, guys. That is an error. Let me change that to blue. Okay, so we're finding the equation of L2. We need the gradient and a point. The point is 4, 7. The gradient I don't have, but the gradient of L1. So gradient of L1 is, if we remember, our y equals mx plus c. What's our m? Well, it's this. It's the number that comes before the x. So the gradient of L1 is -2. Therefore, gradient of L2 is a half. Remember, guys, we flip. That's like -2 over 1. We flip it and change the sign, so it becomes positive. So the gradient of L2 is a half. Now I can say that the gradient, so the point is 4, 7, and the gradient is a half. So I'm going to find the equation of the line. I like to use this formula, guys. Y minus y1 equals m into x minus x1. Sub in our point, y minus 7, because y1 is 7. That's my x1, y1. And m is a half. A half into x minus x1, which is 4. Then he says, so this is my equation of the line. I don't necessarily have to write it in any other form yet, so let's just leave it like that. It says find the coordinates of the point where L2 crosses the x-axis. It crosses x-axis when, so any line or any curve or anything crosses the x-axis when y equals 0. That is because the x-axis is y equals 0. So it crosses the x-axis when y is 0, it crosses the y-axis when x is 0. So it crosses the x-axis when y is equal to 0. So I'm going to sub in 0 in for y. So now I have 0 minus 7, or just minus 7, equals a half x minus 4. Now I need to basically find x. So I'm going to multiply by 2, which gives me negative 14 equals x minus 4. Let's just multiply both sides by 2. 7 times 2 is 14, and it disappears from here because 2 times a half is 1. And then I'm going to add 4 here, so x is equal to minus 14 plus 4, which is minus 10. So the coordinates of the point where it crosses the x-axis, I know that's going to be 0 because y has to be 0, and this has to be negative 10. Okay, that's difficult, guys, obviously. Yeah, there isn't really an easier way to do it. I wrote out a lot here just because I wanted to explain it clearly, but so long as you find the gradient of this line, which means when you can flip it and change the sign and you have the gradient of this line. You then find the equation of this line, however you want to do it. If you want to do y equals mx plus c, it's fine. Once you have the equation of this line, you substitute y equals 0 and you get your point. But definitely that's the hardest question in this paper so far. Okay, question 14. Work out the value of x. Okay, this, guys, looks extremely difficult, but if you can see that this is all about 2's, base 2's. So 128 is actually 2 to the power of what? Well, if you don't know, just go 2 times 2, which is 4, times 2 is 8, times 2 again is 16, then 32, then 64, and then 128. So it's 7. 2 to the power of 7 is 128. Now, just in case you're not sure, do 2, well, just do 2 to the power of 7, like this. 2 to the power of 7 is 128. Okay, so I'm going to write everything with a base 2. Now, this next step is probably the most tricky. So 4, forget that 2 to the x for a second. 4 is 2 squared. So instead of writing 4, I've just written 2 squared. And it's 4 to the power of 2x, so it's 2 squared to the power of 2x. And then this is a times, 2 to the x. I'm just going to use a dot, guys. I prefer the dot when I'm using lots of x's. Okay, now, next step, 2 to the power of 7 equals, one of the rules of indices, I think our third rule, is when I have a power raised to another power, I multiply the powers. So 2 times 2x is 4x. So 2 to the power of 4x, this times this, times 2 to the power of x. My first rule of indices is when I'm multiplying and the bases are the same, I add the indices. So 2 to the 4x times 2 to the 1x, 4x plus x is 5x. Okay, that's the hard bit down, guys. Once I have it like this, it's like 2 to the power of something equals 2 to the power of something. These two things have to be the same, obviously, because it's the only way they could be equal. So I just write, okay, 7 equals 5x, x equals 7 over 5. And that's it. I can write 7 over 5. Or if you want to put it as a decimal, that is 1.4. Okay. Question 15. So we have a Venn diagram, universal set, and A, B, and C within the universal set. 7, 3, 8, 1, 4, 9 represent the numbers of elements. So I always find this confusing, guys, whether these numbers are elements or whether they're numbers of elements. Now it always tells you, but you have to read the question very carefully. These are the numbers of elements. So essentially, this means there are 7 elements here, there are 3 elements here, there are 8 elements here, etc. The little n means find the number of elements in A union B. So the number of elements in A union B will be, what's A union B first? Well, it's everything in A or B. So all of these, if you're anywhere in A or B, you're good. So it's going to be 7 plus 3 plus 8 plus 1, which is 19. Now this is why I say it's confusing. Sometimes these are just elements, and then the number of elements will be 1, 2, 3, 4, because there's 4 elements. But these represent how many elements are here. So really there's 7 here. Hence, I add them up and I get 19. Next one. The number of elements again in not A intersection C, right? I need it to be in C, but not in A. So it's not allowed to be A, and it has to be in C. But A and C, there's nothing in both of them. So not A and C, this means not A and in C. So how many elements are not in A and in C? Well, it's this guy and this guy. They are both in C, and they're not in A. So it's 4 plus 1, which is 5. Part 3, number of elements again. Not in A, union not in B. Right, so now this guy's is tricky because I have to go everything that's not in A. So I'm actually going to write out here what's not in A. Not in A will be this 8, this 1. I should maybe say a number of elements not in A. So this 8, this 1, this 4, and this 9. They are not in A. The number of elements that are not in B will be, what's again, let's look at what's, this is B, something like that. What's not in B? Well, 7, 4, and 9. So I have my 7 plus 4 plus 9. Now, I've already included these 9, so I need to be a bit careful here. I've already included the 9, so I'm not going to include them again. So if I need to get the union of both of these. So the union will be, I need to count this 8, I need to count the 7, I need to count the 1, I need to count the 4. And by the way, guys, the 4, both the 4 and the 9, I'm not going to count them twice. So I'm going to add up 8, so the number in not A union not B. So it's the union of these two sets. So it'll be the 8, the 1, the 4, the 9, the 8, 1, the 4, the 9, and the 7. And this is 9 plus 4 is 13, plus 7 is 20, plus 9 is 29. So this equals 29. Now some of you, no doubt, will ask, hang on, you said not in A, but you included the 7. And yes, I did include the 7 because that's part of the not in B set. Now, I'm well aware that's very confusing, but because it's the union, I have to include everything that is not in A, and I have to include everything that's not in B. Now, this guy is not in B, so I have to include it. This guy is not in A, so I have to include it. In fact, the only thing that I'm not including in this whole question is this 3. So it's actually just 7 plus 8 plus 1 plus 4 plus 9. Okay, anyway, hopefully that makes sense, guys. I know that that last one always causes problems. Okay, question 16. So there are 8 counters in a bag. There's a number on each counter. These are the numbers. Fiona takes at random 3 of the counters. It's bolded, guys, but I'm going to underline it anyway. And then she adds the numbers. I'm going to underline this. This is very important. She's going to add the numbers on the 3 counters to get a total. Work out the probability that her total is an odd number. Okay, so I'm going to write this here. 5 odds. 1, 2, 3, 4, 5. There's 5 odd numbers, and there's 3 even numbers. 1, 2, 3. How can I add 3 numbers and get an odd number? Well, if I do, let's go even plus even plus even. If I add 3 even numbers, I will get an even number. Think about it. 2 plus 4 plus 6 is an even number. If I add 2 even numbers and then an odd number, I'll get an odd number. Because 2 evens will give me an even, and then plus the odd will give me the odd. If I add 1 even and 2 odds, I'm going to get an even number because the 2 odds give me an even. Think about it. 5 plus 7 gives me 12. I get an even number. And then finally, if I do odd plus odd plus odd, that will give me an odd because 2 odds give me an even. Even plus odd gives me the odd. Right, so that's the first thing definitely you need to understand. Then I need to decide, right, I'm taking this one and this one. So I need either 1 odd or 3 odds. I'm going to write that down, guys, because that's definitely worth a mark. 1 odd or 3 odds. Now, the way I get 1 odd would be, well, sorry, I'll do the 3 odds first. The way I get 3 odds is odd, odd, odd. The way I can get 1 odd is either odd, even, 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 odd, even, or even, even, odd. So there's 3 different ways. Okay. Let's write down the probability of. So I'm going to get the these are the 4 different things that can happen. This, 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 or this. I'm going to start with odd, odd, odd. The probability of getting 3 odds is, how many odds are there? 5. How many in total are there? 8. So the first one is 5 out of 8. But I need to multiply it by the next one. Now, if I take out 1 odd like this, how many odds are left? Well, there's 4 left because I've taken 1. And how many counters? 1, 2, 3, 4, 5, 6, 7. There's 7 left because I've taken 1. So I have to subtract 1 from this. Now that's obviously that's not straightforward. Well, it's straightforward to subtract 1, but it's not straightforward why you're doing this. But hopefully, guys, you can understand that. This is probability without replacement. She's not putting the counter back. She's taking 3 of them. So she's going to hold 3 in her hand. So she's not actually putting the counters back. Same thing here. Now there's 3 left out of 6. So this is equal to 4 times 5 times 6. Sorry, 4 times 5 times 3. I'm just going to do this on my calculator, guys. do this. 5 times 4 times 3 over 8 times 7 times 6, and that gives me 5 over 28. Nice. Next one, probability that I get odd, then even, right? So what is the probability I get an odd on the first throw? Well, that's going to be the same as this, 5 out of 8. But now even is different, guys, because there's only 3 evens in total. So but there's still 3 left because I've only taken an odd. But it's out of 7 because I've taken an odd, taking this one. There's 3 even, 1, 2, 3 out of 7. 1, 2, 3, 4, 5, 6, 7. Similarly, now I've taken an even, so there's only 2 evens left, and it's out of 6. So this is, I'll have to use my calculator again. 5 times 4 times 3. Oh, sorry, 5 times 3. Careful. Times 2 over 8. 8 times 7. 8 times 7 times 6. 5 over 56. 5 over 56. And then I'm going to do probability of even, odd, even. Now, those of you who are super smart may recognize that this is actually going to be the same probability as this. In fact, these 3 are all the same. They're all going to be 5 over 56. I'll show you why just by doing the math, and then you can decide if you want to actually show the work or not, but you wouldn't have to. So even is 3 out of 8 because there's 3 even and 8 in total. Then odd is 5 out of 7 because there's still 5 odd out of 7 because I've taken 1. And now there's 4 odd out of 6. Now look, the numerator is 5, 3, 2. The numerator here is, hang on a second, what have I done? Yeah, sorry guys, I made a mistake. Very careful, go back, sorry. It was even, so this was right. Even is 3 over 8 because it's 3 even, total of 8. Odd, this is correct. There's 5 odd out of 7. And now I need another even. I did another odd. So it's even, odd, even. So now there's 2 out of 6. Now look, the numerators here are 5, 3, 2. Here it's 3, 5, 2. It's the same because we're multiplying. 8, 7, 6, 8, 7, 6. So this gives you the same answer. And you'll notice, guys, if you want to do it, you can, but I'm just actually going to do even, odd equals 5 over 56 as well. Now, that's not the final answer because it says work out the probability that our total is an odd number. So it could be this, or this, or this, or this. So the probability of odd are 3. Probability that the sum is odd. You can write it like that if you want. You can put anything you want in brackets there, guys. But it's the probability of this happening. The probability that the sum is odd is equal to 5 over 56 times 3 if you want, or just 5 over 56 plus 5 over 56 plus 5 over 56. That's this plus this plus this, and then plus the 5 over 28 as well. So plus 5 over 28, and this gives me, let's do it. Well, I'm going to do this in my head, guys. That's 15 out of 56. 15 out of 56 because 5 plus 5 plus 5 is 15. And now I'm going to do plus 5 out of 28. I'll let the calculator do that. And it's 25 out of 56. So it's 25 out of 56. 25 out of 56. Okay, that's question 16. Question 17. Use algebra to show that this equals this, right? So guys, you have to show you're working here correctly. First step is to say, let, I usually just use X, but let's just use X. You can use whatever letter you want. let x equal, and then we write this out, 0.4. The dot over the 3 and 6 means they are the recurring numbers. So the 3 is the first, 6 is the last. So it's just 3, 6, 3, 6, 3, 6, 3, 6, forever and ever. Okay, then I have to multiply this by 10. I do 10x, but I'm going to multiply both sides of the equation by 10. So this becomes 4.363636 dot dot dot. Now I have to keep multiplying by 10 until I get to a situation where the decimals are the same. Here the decimals are 4363636, and here the decimal is 363636. That's no good. What I mean by is the numbers after the decimal point have to be the same. These are not the same. So I have to go again. 100x. Now I multiply this by 100. Or sorry, this by 10 or this by 100. So it's 43.636363 dot dot dot. Is this the same? No, because this is 43636, this is 3636, and this is 63636. So it's still not the same, so I still have to go again. 1000x equals 436.363636. Okay, now the decimals are the same. Look at them here. So what I'm going to do is I'm going to do 1000. I need to do the two that are the same. So which two are the same? Let me draw a rectangle here if I can. Look at that. Okay, this one and this one. Okay, why am I saying they're the same? Well, because the decimal points, this is the first time the numbers or the digits after the decimal point are the same. 363636, and here's 363636. Now I subtract them. I do 1000x minus 10x. I can write it here. 1000x 1000x, excuse me, minus 10x. So 1000x minus 10x is, well, what's 1000 minus 10? It's 990. So 990x is equal to, and I need to do this minus this. Now guys, use your calculator if you want. I'm going to use my calculator. Don't be ashamed to use your calculator. 436.363636 whatever, minus, and you'll see now the reason I need to keep going until the decimals are the same is because they will disappear now. So it's 436 minus 363636 forever, but this, the 4.363636 forever, will also, they will subtract each other, so it'll disappear, and we're just left with 432. So it's just 436 minus 4, which is 432. Then I can say x is equal to 432 over 990. And guess what 432 over 990 is? Well, you can put that into your calculator. 432 over 990 gives me 24 over 55, which I expected because it's there, equals 24 over 55. Yes, do write that last line. 2 marks, guys, seems a bit harsh for all that working, but c'est la vie, and it is question 17. 17b. Show that this plus this can be expressed in the form root a, where root a is an integer. Show you're working clearly. Okay. First thing to note, root 20, I can write root 20 as root 4 times root 5. So it's good to always look for the square numbers within these surds. So these are called surds. So root 20 I can write as root 4 times root 5. 4 times 5 is 20. The square number is 4. The reason I like the square number is because I can just write that now as 2. But anyway, I'll get to that. Root 80 I can write as root 16 times root 5. Now why did I choose 16 and 5? Well, these are factors. 16 times 5 is 80. But the 16 is a square number, so I can write that as 4. So first, let's write it like this. This is then equal to 2 root 5, because root 4 is 2, so it's 2 root 5, plus 4 root 5, because root 16 is 4, all over root 3. That's still the same. Okay, now to get rid of this root, guys, how do I get rid of a root? Well, or how do I rationalize the denominator? To remove a root from the denominator, I need to multiply by that root. Now, I can't just multiply something by root 3. I have to keep it because it has to stay the same. So what I do is I multiply by root 3 over root 3. So I just multiply by the same, well, I multiply by 1 essentially. So it doesn't change this. This is now still going to be the exact same thing. I'm just multiplying by 1. But the root 3 times root 3 will give me 3, which is what I want. So I have to expand this, guys, the long way. I have to do this times this plus this times this, and then this, the denominator times the denominator. So 2 root 5 times root 3 is equal to 2 root 15. Notice, guys, root 5 times root 3 is root 15. Plus 4 root 5 times root 3 is 4 root 15. 5 times 3 is 15. All over, this is the bit, guys, this was the key to the whole question, is to multiply by this over this. Root 3 times root 3 is 3. If you don't believe me, check your calculator, but it makes sense because root 3 squared gives me 3. Nearly done. 2 root 15 plus 4 root 15 is 6 root 15 over 3. And then 6 divided by 2 is 2. So this is 2 root 15. Now, this is not the form that he wants it in, guys, so we have to be super careful here. He wants it in the form root a, where a is an integer. So I have to change this. This bit is actually a bit annoying. I'm going to change this to, instead of writing 2 root 15, I'm going to write root 4 root 15. Now, how did I do that? Well, the square root of 4 is 2. So these two things are the same thing. Why did I do that? Well, the reason I did that is because now I can just multiply these two together and it gives me root 60. Obviously, guys, that is a difficult question. Now, you could potentially have multiplied by root 3 over root 3 at the start, but I think that's harder because you end up with kind of bigger numbers. So this is my preferred way to do it. If you did it the other way, where you multiply by root 3 over root 3 here straight away as your first step, and you ended up with root 60, that is absolutely fine. Obviously, that's a really hard question, guys. And it's 5 marks for both of these parts. So it's, yeah, question 17, not easy. Question 18. Solve the simultaneous equations. Show clear algebraic working. Right, these guys are always a struggle. It's 5 marks just for this equation, or just for this one question. It's not easy. So at least they've already put the linear equation in the form where x equals something. So it's already in a nice form. I don't need to rearrange this. The way we do these questions is we put this one, the linear equation, into the nonlinear equation and then solve this. When I say put it into it, what I mean is, instead of x, I'm going to put 2y minus 3. So I'm going to do 2 times, instead of x, I'm going to put 2y minus 3 because x equals 2y minus 3. So I can do that. Instead of x, I'm putting 2y minus 3, but it's squared, plus 3y squared equals 14. Now, why did I do that, I guess is a better question. Because now I just have an equation with y's in it. There's no x's, so I can just find y first. I've kind of, if you remember your linear simultaneous equations, we have eliminated x, or we have at least substituted to remove x. So we just have y. Now, this still isn't easy, guys, because I have to do 2y minus 3 squared. I'll do it at the side, because, guys, trust me when I say loads of people will make this mistake. 2y minus 3 times 2y minus 3. It's not 4y squared plus 9 or anything like that. You have to do it the long way. You have to go this times this, this times this, this times this, this times this. And we get 2y times 2y is 4y squared. 2y times minus 3 is minus 6y. Minus 3 times 2y is minus 6y. And minus 3 times minus 3 is plus 9, giving me 4y squared minus 12y plus 9. I'm going to put that here. So it's 2 times this, 4y squared minus 12y plus 9. Do it at the side, guys, less likely to make a mistake. Plus 3y squared equals 14. Okay, multiply this out. This times this is 8y squared minus 24y plus 18 plus 3y squared equals 14. Add the y squares together. 8y squared plus 3y squared is 11y squared. Minus 24y is on its own, minus 24y. And then 18 minus 14 is 4. So it's plus 4 equals 0. Now, guys, this is obviously not a nice quadratic to factorize, but because it's 11y squared, you know it has to be, because 11 is a prime number, it has to be 11y and y. If at this point you want to use your calculator, you can use your calculator here. We're going to go here down to this one, which is a equation function, and then polynomial is 2, the degree is 2, and I'm going to put 11 minus 24 and 4, because those are my numbers, and it'll give me x1 equals 2 and x2 equals 2 over 11, right? So you can use them, but it is important, guys, that you show the factorizing. So you want to factorize this here. So the way I factorize it is I say the factors of 11y squared are 11y and y. Factors of 4 are 4 and 1 or 2 and 2. Now 4 and 1 is not going to help me, but 2 and 2 will help me, because I'll get 22y and 2y adding together give me 24y, or minusing them will give me the minus 24y. So these two have to be negative. So the factors are 11y minus 2 times y minus 2. Now sometimes, guys, students who really hate this, and God knows there are many students that do not like factorizing quadratics, you can solve it using your calculator and then kind of go backwards to show the factorizing. But these are the two values we're going to use, that we're going to use anyway. So this is equal to 0, meaning 11y minus 2 equals 0, or y minus 2 equals 0. 11y equals 2, and y equals 2 over 11, 2 over 11, and here y is equal to 2. So these are my two y values. 2 over 11 and y equals 2. But for each y value, I need an x value. So I'll do it here. For y equals, I'll start with 2, guys, because that's the easier one. For y equals 2, x equals, I'm going to use this equation again, this one, but I'm going to sub in 2 for y. So it's 2 times 2 minus 3, because y is 2, equals 4 minus 3, which is 1. 4 minus 3 equals 1. For y equals 2 over 11, x equals 2 times 2 over 11. Again, I'm subbing this in here. Minus 3, which is 4 over 11 minus 3. At this point, guys, I'll just use my calculator. 1. 4 over 11 minus 3 is minus 29 over 11. Minus 29 over 11. Now be super careful, guys. Your answers are, so actually let me change this to green just so it's clear. The y equals 2 goes with the x, I'll call that x. The y equals 2 goes with the x equals 1, because that's, I subbed in y equals 2. The y equals 2 over 11 goes with the x is minus 29 over 11, because I subbed it in there. So just be crystal clear, you've two solutions. You have your x equals 1 and y equals 2. Put a box around this, like so. And then you have your x equals minus 29 over 11, y equals 2 over 11. Put that in a box there as well. Okay, there's your two solutions, right? Fine. Question 19. So A equals P minus Q over T. P is 8.4 correct to two significant figures. Q is 6.3 correct to two significant figures. T is 0.24 correct to two significant figures. So everything's correct to two significant figures. Work out an upper bound for A, the value of A. Show you're working clearly. Give your answer correct to one decimal place. Okay. Firstly, we need to decide, do we want to make P big? Do we want to make Q big, or do we want to make P big or small, Q big or small, and T big or small? Well, I want P, because I want to make A big. To make A big, so, and when I say big, I mean I want to find the upper bound. So I'm going to find the biggest possible number A can be. To make A big, P must be big. I want to make P as big as possible. So P is big. I'm going to subtract Q. So think about it. If I'm going to subtract a number, I actually want that number. If I said to you, you want your bank account to be as big as possible, and I'm going to subtract some money, then you want the thing I'm going to subtract, which is Q, to be small. If you had a bank account and I said I'm going to subtract some money, do you want me to subtract a big amount of money or a small amount of money? You'd say please subtract a small amount of money. So Q is small. And then I'm going to divide by a number. Now if you're going to divide, again I'll use your bank account analogy. If you have $1,000 in your bank account and I say I'm going to divide it by a number, do you want me to divide it by a big number or a small number? Well, you want to divide it by a small number. The smaller the better. So T has to be small. So that's the first thing that you need to get straight in your head, guys. This is a difficult question. It's question 19. But I need P to be big. Because I'm making A big, I want P to be big, I want Q to be small, and I want T to be small. Right, once you understand that, don't move on until you understand that. Once you understand that, then we need to try and make P big. So let's look at P. I like to draw number lines, guys, for these. And I like to put 8.4 bang in the middle. It's been rounded to two significant figures. So if it's been rounded to two significant figures, the next number up would be 8.5. That's the next, if we're going with two significant figures, the next one up is 8.5, and the next one down is 8.3. The upper bound, because remember we're making P big, the upper bound is going to be halfway between these two numbers. The lower bound is here, halfway between these two numbers. Upper bound, lower bound. What's halfway between 8.4 and 8.5? Well, it's 8.45. That's the upper bound for 8.4. Okay, let's do Q. This is Q. 6.3, same thing. I'm going to put it in the middle. 6.3. The next number down, if we're dealing with two significant figures, is 6.2. The next number up would be 6.4. The upper bound and the lower bound. Upper bound is, lower bound is here. Upper bound is here, halfway between the numbers. Now I want, let me do that again. I want for Q, do I want Q to be big or do I want Q to be small? Well, we decided I want Q to be small. So I'm going to put it here. It's the lower bound for Q. And it's halfway between 6.2 and 6.3, which is 6.25. 6.25. Lastly, for T. Now this is particularly hard, guys, because these are one decimal place and this is two decimal places, but it's all two significant figures. So it's really testing your understanding of rounding. Okay, it's 0.27. So 0.27 is here. The next one up is 0.28, and the next one down is 0.26. Same thing. Upper bound is somewhere here. Lower bound is somewhere here. Do I want to make T big or small? I want to make it small. So it's the lower bound, which is 0.265. Again, I'm adding on this 5, guys, because it's halfway between these two. If you're not sure, you can add them together and divide by 2. Okay, so the graph really helps here, guys, understanding. And then I just say, okay, what's A then? Well, A is equal to P minus Q over T. And then I'm going to sub in these values. P is my 8.45. Q is my 6.25. And T is my 0.265. Definitely use a calculator for this. Calculator, please. Take out this. 8.45 minus 6.25 all over 0.265 gives me 440 over 53, which is 8.30188. Does he say to give your answer to one decimal place? So I'm going to write first 8.3019, 8.3019. I'm just putting a few more numbers down, and then to one decimal place 8.3. You can write if you want one decimal place, but they did ask for that, so there you go. Okay, obviously, guys, not not a short question, but I think when you draw out the number lines properly, maybe fully understand this, then it's manageable for everyone. Okay, question 20. Solve the inequality. Right, guys, this question is worth 4 marks, but I have done this before and I'll do it again. You can get the answer to this question on your calculator. I like to do that straight away. Now, you won't get any marks for this. if you write it down, but it does kind of, well, it will help you. It will help you to kind of know if you're on the right track. So I'm going to B on this calculator, it's inequality. The degree of the polynomial, that's just 2 because it's a quadratic. So I press 2. Then which one of these is it? Is it greater than 0, less than 0, greater and equal, or greater or less than and equal? Well, it's the first one because it's greater than. So I'm just going to press 1. My numbers are 4, -5, and -6. Press enter, and I get the answer. X is greater than 2 or less than -3/4. So let's write that down. X is less than -3/4, comma, X is greater than 2. That's the answer. Now, as I say, that's worth 0 marks, obviously, because that was way too easy. And they want us to work for our marks. So we need to show some working. How do we do it? Well, we need to factorize. Now, the fact that we have our -3/4 and our 2 might help us to factorize, but I am going to try and factorize this. How do we do it? Well, I'm going to do 2x and 2x, because 2x times 2x gives me my 4x squared. And then I need to decide, am I going to do 3 and 2? If I do 3 and 2, that'll give me 4x. And because, guys, the way I do this, by the way, definitely there's like 7 or 8 different ways of factorizing quadratics. The way I do it is I find the factors of 4x squared, 2x and 2x, factors of 6, 3 and 2, and then I cross multiply, because you multiply the opposite bracket, and I get 4x and 6x, and I need to get 5x, so that's no good. So that's not going to work. So then I try, and you just have to try trial and error. 6 and 1, that's going to give me 12x and 2x. That's no good because it's not going to give me 5. So actually 2 and 2 is no good. So I'm going to try 4 and 1, 4x and x. Then I will try 6 and 1 is not going to work, but 3 and 2 I have a feeling will work. If I do 3 there and 2 there, this will work because I'm going to get 8x and I'm going to get 3x. This will give me 8x and this will give me 3x, and I want to get minus 5x. So if I put minus here, minus 8x plus 3x, that will give me the factors. Now as well, I think I told you guys about the trick where you can kind of work backwards, because we knew the answer was minus 3/4. So you can see how here I'm going to get minus 3/4. And this guy is x minus 2. This is greater. This has to be greater than 0. Okay, now what I always do, guys, with these inequalities is sketch the graph. What does this actually look like? So I'm going to draw a set of axes. What does this graph actually look like? So this is x, this is y. Now it's a quadratic, it's a smiley face because it's a positive quadratic. It's going to go through -6, so it's going to go down like this. But the roots of the quadratic, let's consider 4x plus 3 equals 0, then 4x equals -3, and x equals -3/4. That is my solution to the quadratic equation if this equaled 0. Now it doesn't equal 0, it's greater than 0, but this will give me my root. So that gives me my first root, or my x minus 2 equals 0, x equals 2, that gives me my second root. Now look, guys, note, these are my solutions. Less than -3/4 and greater than 2. But I always find these are challenging questions, guys, because we don't know where to put the sign yet. But the fact that you have the answer in your calculator, once you get to here, you're fine, because you can actually put down your answer. Just to show I want to complete this question though to help you understand what's happening. If I was to draw this curve like this, hopefully that is okay, that's not bad. If I was to draw this curve, this point is -3/4 and this point is 2. These are my two solutions, my two roots. And the question is, where is this graph? Because this is the graph of this. The blue graph is this thing. Where is this? Where is the graph bigger than 0? Well, bigger than 0 means where is it above the x-axis? So here it's bigger than 0, and here it's bigger than 0. So where is that if I had to write it as x values? Well, this is x is anything bigger than 2 because it's that way, bigger than 2. And here it's x is less than -3/2 because it's this way. Maybe I shouldn't have written that down there, guys. I'll put it up here as well, but it's the same idea. Okay, so hopefully that makes sense. But anyway, even if you didn't draw the graph, you would get the marks because you have this here now, right? So that's actually a big benefit of the calculator. Okay, question 21. Here's the graph of y equals f of x. On the grid above, draw the graph of y equals 2f of x, right? On this grid, I like these questions, guys, because if you know your transformations, you know that this, if you put a 2 in front of the f of x, you multiply the y coordinates by 2. Multiply y coordinate by 2. Because this is going to stretch the graph. It's a vertical stretch, scale factor 2. We multiply the y coordinates by 2. So this y coordinate is -1. So -1 times 2 is -2. This y coordinate, and I only have to pick the end points because it's a straight line. This is 3. What's 3 times 2? 6. And then this is also -1. -1 times 2 is -2. So all I need to do now is join these graphs. I don't know what this value is. That says 1.75. That means when I join these two lines together here, it'll be double this. So 1.75 times 2, well, whatever, 3. It's close to 3.5, but it's whatever this is. Double it, brings it to here, and then finally join this to there. Okay, that's part A. Here's a graph. On the grid above, draw y equals f of -x. So f of -x, we just multiply the x coordinates, by -1. -1 because it's -1x, if you like. And the x coordinates because it's inside the brackets. Notice this one, the 2 is outside the brackets. It's 2f of x. If it was f of 2x, I'd be multiplying the x coordinates, although by 1/2. I'll get to that at a different question. Here I multiply the x coordinates by -1. So what's the x coordinate here? -2. So my x coordinate becomes -1. My x coordinate here, oh no, sorry, what am I doing? I need to multiply them by -1. So I'm going to multiply this -2 by -1, brings it here to 2. I multiply this coordinate by -1, it brings it to here, -4. And I multiply this coordinate by -1, brings it here to -1. So what's actually happened, guys, and I did it that way so you could see why it happened, it is a reflection in the y-axis, and that's why it's a reflection in the y-axis, because by multiplying the x coordinates by -1, you end up just flipping it to either the negative or the positive, which is the same as reflecting it in that axis. Okay, are we nearly finished? No. Question 22. Express this as a single fraction in its simplest form, right? This is obviously, guys, a fairly horrible question. Okay, let's do it. So, this involves a lot of factorizing. The first one, the numerator. The numerator, I'm going to tell you what it is, and then I'm going to show you how I did it. It's 2x plus 5 times 2x minus 5. That is because this is a difference of two squares. The difference of two squares is a rule, guys. It's a squared minus b squared. If you have a squared minus b squared, the factors are a plus b times a minus b. If you don't believe me, multiply this out the long way and you'll get a squared minus b squared. So this guy is actually 2x squared minus 5 squared, because 2x all squared is 4x squared and 5 squared is 25. Hence I get 2x plus 5, a plus b, 2x minus 5, 2x or a minus b. 2x plus 5, 2x minus 5. Do not write in this area, guys. Look, watch this. There we go. Okay, that's that numerator. The denominator is, I am going to factorize this thing, this 5x squared plus 2x minus 7. So guys, if you don't like factorizing quadratics, you are not going to like this question. 5x squared plus 2x minus 7. The factors are 5x and x, because it's a prime number, and 7 and 1, it has to be because it's a prime number. I'm going to put the 7 there and the 1 there, and I'm going to put the plus there and the minus there. That is because when I multiply across like this, I get 7x minus 5x gives me 2x, which I wanted. Again, guys, if you know how to factorize a different way than that, by all means use it, so long as you get the factors. You can also use the calculator hack where you work backwards, but this is how I do it, and that's the factors. It's a difficult skill to master. So this is 5x plus 7 times x minus 1. Okay, this is then all times. I need to make this into a single fraction, guys. I'm not gonna lie, this is really difficult, so don't panic if you can't do this. This is a algebraic fraction. What I'm doing is getting a common denominator I get from doing this times this, and then I have to do 2 times 2x minus 5 minus 3 times x minus 3. This is how I add two fractions. I get a common denominator, and then I get equivalent fractions, which is this times this and this times this. Okay, then I'm going to keep this first bit here. I'm actually going to copy and paste. Guys, I know that's cheating, but whatever. So it's this times. Now, the numerator here I'm going to multiply out. It becomes 4x minus 10 minus 3x plus 9. So that's just 2 times 2x is 4x, 2 times minus 5 is minus 10, minus 3 times x is minus 3x, minus 3 times minus 3 is plus 9. I'm going to keep this denominator, x minus 3 times 2x minus 5. Okay, this I should say is equal. This equals this. Equals. I'm going to copy and paste again. This, I like this. It's factorized. It's nice. I'm hoping things cancel. Leave it like that. This then becomes 4x minus 3x is x, and minus 10 plus 9 is minus 1. Nice. So this is just one nice thing here. And then this is x minus 3 times 2x minus 5. How many marks is this, guys? This is only 4 marks. That's not very kind. Okay, but at this stage, x minus 1 cancels. Nice. 2x minus 5 cancels. Nice. So I'm just left with 2x plus 5 in the numerator and 5x plus 7 times x minus 3 in the denominator. Now guys, that's obviously, if you don't like algebra, that is obviously, I just want to put that down here, an extremely difficult question if you're not good at factorizing, multiplying out algebraic fractions and all things like that. I would advise you all to work on this kind of stuff. It gives you a great advantage if you're really good at algebraic manipulation like this one. Like some of these questions I actually do find quite difficult, but this one isn't one of them because I know how to do all this. I'm quite comfortable factorizing, I'm comfortable multiplying out, I'm comfortable cancelling. So I knew, as soon as I saw this question, I knew what I had to do. There are other questions where I'm like, it takes me quite a while to figure out what exactly they're asking. But as I say, if you're not good at factorizing and multiplying out, that question is going to be a big problem. Okay, question 22 done. Question 23. Okay, vectors. I know it's vectors because of this little arrow here. OA is A and OB is B. C is the midpoint of OA. D is the midpoint of OAB such that this equals this. E is the point such that OB equals 2B, right? Obviously, guys, when you read that, it's very confusing. But if you draw it, it makes life a lot better. So I'm going to draw this. This is O. This is the origin. This is the start. OA is A. So from here to here, this is the point A, and this vector OA is little a. Then O to B, let's put it somewhere like here. I don't know which way they go, but it doesn't matter, so long as it's going from O to A and O to B and the arrow's in the right way. It then says C is the midpoint of OA, right? So I need to put a C. Hang on, I just want to move this. Hang on. This bit here, I want to move out of the way because I'm going to put a C in the middle here. So this is the point C. And C is halfway between O and A. Now I haven't even read the question yet, but I want to draw this diagram because it's going to help me understand it. D is the point on AB, so D is going to be on AB, which is on this line here, such that A to D and then D to B is 3 to 1. So that means, just be careful guys, 3 to 1 means 3/4 will be from A to D and 1/4 will be from 1 to B. So it'll actually be 3/4 along the way. So it's somewhere here. Let's put it there. This is D. E is the point on OB, so it's on this line, such that OB equals 2BE. Okay, so E is the point, sorry, it's not on this line, so let's just be careful here. E is the point such that OB equals 2BE. Okay, so E is actually, guys, down here. So if I actually continue this line, I'm actually going to start it here again, and I'm going to continue it. So it's basically saying OB is twice as long as BE. So E is down here somewhere. This point here is E. Now, you might, okay, that's the first bit that I would say is tricky. You're like, how did you know it was there? Well, because of this, it says OB, so O to B is 2B to E. So that means from here to here, this OB, this guy, is twice this guy, him. So it has to be parallel. It has to be going in the same direction. So I just obviously guessed that's about half, a bit more than half, whatever. But it's half because two of them, I need two BEs to equal one OB. Okay, so that's my diagram. Then it says, using a vector method, prove that the points C, D, and E lie on the same straight line. So he's claiming that, my diagram isn't perfect, but it might be close enough. He's saying that C to D to E, actually that's pretty good. Obviously I've just made up the diagram, guys, but and you don't have to show this, but I wanted you to understand what's happening. I might just move D as a bit of a cheat there. Okay, so he's saying prove that C to D to E is a straight line. Now to do that, you have to show, I'm going to write down what I want to show. We need to show that CD is parallel to DE. If I can show that, then I have shown that they're on the straight line, because they both go through D, and if they're parallel, they're both going the same direction. So if they're going the same direction and they both pass through the same point, then they have to be on the same straight line, if that makes sense. Now, guys, this is a really, really hard vector question, just to let you know. Again, I know I keep apologizing, but it's just so you don't feel too bad if you find this difficult. Okay, I need to show that CD is parallel to D. To do that, I need to basically get CD, and I need to get DE. So I'll write up, well, let's write here. CD, to get from C to D, C to D, I need to go C to A plus A to D. Now C to A is a half little a. It's a half little a because we said C was in the middle of this line, which is OA. So CA is a half of this, because it just goes from here to here, half of A. AD is 3/4 of AB. Now, how did I know that? Let me go back here. I know it's 3/4 because it says it's in the ratio 3:1. So if it's in the ratio of 3:1, that means this is 3/4 and this is 1/4 of the line. So this is 3/4 of AB, 3/4 of AB, and this is 1/4 of AB. So it's 3/4 of AB. Now at the side, guys, AB, I'm gonna write this over here actually, AB is equal to minus A plus B, minus A plus B, or B minus A. How did I do that? Well, I'm going to go minus A that way, plus B that way. So AB is B minus A. So now I can sub, this is a half A, and instead of AB, I'm going to do 3/4 B minus A, B minus A. Multiply this out, a half A plus 3/4 B minus 3/4 A. Finally, a half A minus 3/4 A, which is minus, or 2/4 A minus 3/4 A is minus 1/4 A plus 3/4 B. Okay, that is CD. So CD equals that. Okay, next step, I need to get DE. Let's do that here. Let's do a line like this. Okay, DE, because I am trying to show that CD is parallel to DE. So if I get it, if it looks something like this, a multiple of that, then I'm good. DE is equal to DB, D to B, so DB, plus BE. So D to B plus B to E. DB is a quarter of AB. And AB is B minus A, so it's a quarter B minus A because of this. It's 1/4 of this. 1/4 of AB, and this is AB. Plus BE. Now BE, remember, we said it's a half of OB, which is B. So BE is half of this. So a half of B, of little b, because it said that at the start of the question. This equals, we're nearly done guys, a quarter B minus a quarter A plus a half B. A quarter B plus a half B is 3/4 B minus 1/4 A. Now look, CD and DE, they're actually the same. It's minus a quarter A plus 3/4 B. 3/4 B minus a quarter A. They're the same thing. Therefore, they're parallel and on the same line. So I'm going to actually write down CD equals DE. Therefore, parallel, and as they both pass through D, they are on the same line. Okay, guys, I'll say one more time. That question is extremely difficult. In fact, that's one of the hardest vectors questions I've done in quite a while. Okay, that is question 23. Question 24. Okay, so guys, I don't like these. These are the completing square ones, but it's a minus x squared. I don't like that. So it's minus x squared. I'm going to rearrange it. Minus x squared, minus 4x, and plus 7. Now what I'm actually going to do is I'm going to say minus. I'm going to take out the minus, and I'm going to say minus x plus 4x plus 7. So notice what I've done. I've just taken out a minus here, and this becomes plus, because now it would be minus x minus 4x plus 7, which is the same thing. Then I'm going to, sorry, x squared. Then I'm going to do this completing the square trick here, where I say x plus 2 squared minus 4. Now if you recall, guys, that's how we completed this square. We did x plus 2, we half this, we do x plus 2 squared, and then we subtract this squared. Okay, now note the minus is outside of everything, so put a big bracket outside here, because that minus 4 is with this minus, and the plus 7 is just separate out on its own. Then I'm gonna multiply out this minus. It's minus x plus 2 squared plus 4. So minus this, minus times minus gives me plus, and then the plus 7 is just there on its own, waiting to be added, which we'll do now. So this becomes, and I'll make 4 plus 7 is 11, so I'll put the 11 first, because that's how they have it here. 11 minus x plus 2, 11 minus x plus 2 squared, and that's it done. So the minus, guys, yeah, always causes problems. Next part. Use your answer to part A to solve this equation. 7 minus 4 times y plus 3 minus y plus 3 squared equals 0. Give your answers in the form e plus or minus root f, where e and f are integers. Okay, so basically, guys, when it's in this form, we can write it like this. So I can say 11 minus x plus 2 squared. But he's now saying, look, can you see the similarities? This is 7 minus 4x. This is 7 minus 4y plus 3. This is minus x squared. This is minus y plus 3 squared. So it's basically this, except instead of y, we have, instead of x, we have y plus 3. So I'm going to solve this. I'm going to say this equals 0. I'm going to solve this equation first, because he says use your answer to part A to solve this equation. So I'm going to solve this equation. I'm going to say, well, I'm going to write consider, just to be technical. Consider this equals 0. Solving this, I'm going to add my x plus 2 squared to the other side, x plus 2 squared. I'm then going to get the square root of both sides. Square root of 11 equals x plus 2. And then I'm going to subtract the 2. So x equals minus 2 plus or minus, because he wants that here, plus or minus root 11. But for this equation, x is actually y plus 3. So I'm going to say let x equal y plus 3. Because it's, look, it's like 7 minus 4x minus x squared equals 0. This is the same as this, except x is y plus 3. So why don't we solve this first, and then I can just solve for y, because y plus 3 now is equal to minus 2 plus or minus root 11, which means y is equal to minus 2 minus 3 gives me minus 5 plus or minus root 11. Okay, obviously, guys, not an easy question at all. Finally, the curve C, and this is the final question on the whole paper. So these last 3 questions, guys, I would argue were extremely difficult. But if you're aiming for a 9, you need to know how to do them. The curve C has equation this, okay, y equals 3 minus 5 times x plus 1 squared. The point A is the maximum point on C. Write down the coordinates of A. Right, this is, if you know, guys, that this is the completed square form or the vertex form, you know that this question is actually easy. The answer is minus 1, 3. It's minus 1 because it has to be, whatever this number is, it's negative that number. So if that was negative 1, this would be 1. If this was 10, this is negative 1. The x coordinate is the negative of this number. The reason for it being is because how do I make this function as big as possible? Well, I need to remove this whole part because I'm subtracting it. How do I remove it? Well, if I make x minus 1, it becomes 0. Minus 1 plus 1 is 0. So it's minus 1, and then if this bit does become 0, what am I left with? 3. Hence, that's the maximum value of y. So it's -1, 3. I'll just show you guys how to, if it's in the general form. So if it's y equals a times x minus h squared plus k. When it's in that form, the maximum is hk, or the minimum for that matter. If a was, well, if a is positive, it's a minimum. If a is negative, it's a maximum. So the minimum is always that number there, but the negative of it, and the y coordinate is always that number there. So it doesn't even matter. That's 5, but it doesn't even matter. That number could have been 20, and it's still the same answer. Okay, done, guys. That is the paper. Obviously, last few questions were very challenging, but hey ho, this is IGCSE higher level mathematics, and I'll see you in the next past paper.